So let's take a look at section 8.1, okay, law of sines. Okay, the law of sines is going to be used to solve triangles. Now, we've already solved triangles before. Okay, we've already had a lesson where we did the SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And we've used the Pythagorean theorem to find lengths of sides. And we also found measures of angles. What kind of triangles did we always work with when we did the SOHCAHTOA and the Pythagorean theorem? You can only use that stuff with certain kinds of triangles.
Right triangles?
Yeah, with like a right triangle. All right, so we're going to start working with triangles that are non-right triangles. Okay, so if you have that kind of triangle, that's called oblique. Right? There's two kinds of oblique triangles. You can have an acute triangle, all the angles less than 90, like an equilateral. That's an example of one type of acute. Or you can have an obtuse triangle, where just one angle is more than 90. Obviously, in a triangle, you're never going to have two obtuse angles. It wouldn't be a triangle. Okay, and we got to come up with a new diagram for solving these, because we didn't have a name for the right angle. Okay, we had names for all the sides. We had A, B, C. We had the name for the angle across from side A. Anybody remember what that was? We do use theta sometime, but in a right triangle, we had a specific name for the angle across from A. Alpha. And the one across from B? Beta. Now we're just going to give a name to the one across from C. Okay, so A is still across from alpha. B is still across from beta. C is now going to be across from bird. No, it's not really bird. Anybody know what letter that is? Gamma. That's gamma. Okay. Again, we never named it before. We just always said the right angle. Okay. Now we need to name it. So there's 6 things here to solve for. In each problem, I have to give you 3. I can't give you any 3. For example, if I gave you angle, 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 you couldn't solve that. Think of, from geometry, if you know all the angles in a triangle, all you can determine is similarity. For example, if I said all the angles in a triangle are 60, 60, 60, tell me the length of each side. Well, you can't. Okay, it's equilateral, but all the sides could be 5, they could all be 10. You don't know. Right? Okay, but what I can give you is 2 angles and a side. And there's different ways I can do that. I can give you, I'll kind of circle them on the diagram so you can see. 2 angles and a side, like the first case, would be something like this. You know 2 angles and the side that's between them. So like gamma and beta, and the side between them is A. Okay. Any 2 angles and then the side that connects them. That's angle, side, angle. Okay, side angle, angle. That's where you know a side, an angle, and an angle. But this time the side that you know is not the side that's between the 2 angles. Okay, so I could give you alpha, beta, and B. Or I could give you alpha, beta, and A. That would still be side angle, angle. But if I gave you alpha, C, and beta, now I just gave you the side that's connecting the 2 angles. That's the first type. So any question on that? It's just important that you can recognize a triangle based on the information given, because that's going to tell you whether you use this law or another law we're going to learn. Okay, so that's the types with 2 angles. We already talked about 3 angles. You'll never have that. I can just do 1 angle. I can do side, side angle. That would be like side, side, and now pick an angle that's not between the 2 sides. Alpha. It's 2 sides and an angle. If I did A gamma, and B, that would be side angle side. We're not going to talk about side angle side today. That's something different. We're also not going to talk about side, side, side. That is doable, but not today. Okay, so any questions on those three types? Right, so in geometry, a lot of times you did proofs with these kind of things. We're not using them to do proofs. We're just using them to convey what kind of information you know. Okay, that's all. So anytime you know one of these three cases, these are law of sines problems. And it's only used for these three types. So with law of sines, you're going to see this on a couple tests. Okay, the reason is we're not going to get to law of cosines this week. All right, so every single problem you see on the test, I'm guaranteeing you it's a law of sines problem. But I want to be able to test, if I give you a problem, can you figure out which law to use? So next week we're going to do law of cosines, and on that test, I am going to mix some law of sines and law of cosines problems. So I want to see if you can figure out when to use each one. Right. You will not have to figure that out for this test. They're all law of sines problems. All right, so let's look at the law of sines. Okay, this is a proof that is relatively straightforward and worth doing. I'm not going to prove all parts of the law of sines. I'm going to prove two. And then, by extension, you can figure out the third part. All right. First thing I want to do is draw in an altitude in that triangle. Okay, so let's put in an altitude right there. What have I just done? By drawing in that altitude, I've created some things. Yeah?
You've created two right triangles.
Yeah, created two right triangles. And since this is an altitude and the altitude measures height, H is a good letter to label. And we've got to label a couple other things here. Let's label, this is alpha, which means, what's this side on the left going to be called? Think about it in the perspective of the big triangle. A is across from alpha. Yep. And I'm going to label this side B. So the angle in the lower left will be, go ahead, Josh. Beta, yeah, good. I don't need to label the third angle because I'm only proving two parts of this. So I need two angles. All right. So for now, we're going to cover up the right-hand side. Okay, all I'm going to do is focus on the left part of this triangle. All right. So I have three things labeled. I have H, A, and beta. Okay. I want to use a trig function that's going to use this angle, this side, and that side. Anybody see what trig function would involve beta, H, and A? And if you're not sure, think about what A is called. It's across from the right angle. Figure out that name. Figure out what H is called. It's farthest away from beta. And once you have those two names, there's a trig function that has those in it. Keep in mind what we're proving. Yes, sine. Okay, we're going to use sine. So if you write down sine of beta is opposite over hypotenuse. Okay, now let's solve it for H. Okay, get H by itself. Michael, how would I get H by itself?
Multiply both sides by A.
Right. Usually you have to be careful multiplying both sides by a variable, because if that variable was 0, we just did something we're not allowed to do. But I guarantee you A is not 0.
Isn't it opposite over hypotenuse?
Yes. Yep. So A won't be 0 because it's the length of a side in a triangle. Can't be 0. So that cancels out. And we get A sine beta equals H. Okay, just keep that off to the side for a second. Any questions on that? So that's a formula for H, A sine beta. Okay, now we're going to look at the other half of the triangle. Okay, we're going to do the same thing again. I want to come up with a trig function that's going to involve alpha, H, and B. Shannon, what trig function would involve the side farthest away from alpha and the hypotenuse? Sine again. Yeah. So sine of alpha. And Tahina, what would be my fraction here?
H over B.
Good. H over B. Okay, I want to do the same thing I did before. I'm going to solve, and I'm going to get a formula for H. So how about Brandon? When I solved that for H, what would I get?
B sine alpha.
Yeah. B sine alpha equals H. Okay. Now let's look back at what we did over here. We have H equals A sine beta. And we have H equals B sine alpha. Okay. What other fact could you make from these two? You can take these two facts and kind of combine them together to say a third fact. And that's going to be our law of sines.
A sine beta equals B sine alpha.
Yes. A sine beta equals B sine alpha. And what I'm going to do is I'm going to divide each side by AB and AB. The reason, this gets it in the format of the law of sines. So on the left-hand side, A divided by A cancels. On the right-hand side, B divided by B cancels. Okay, so what we're left with is sine beta over B equals sine alpha over A. And that's the first two parts of the law of sines, which we proved. Okay, just by following the pattern, anybody have a guess what the third part of this would be? Yeah?
Would it be C sine gamma over C?
So we have sine of an angle over a side, sine of an angle over a side, sine of an angle over a side. So sine of,
Gamma over C.
yeah, just gamma in the top, just C in the bottom. Okay? So this part we didn't prove. You could prove it by drawing in an altitude from another angle and going through the same part again. The only tricky part about drawing an altitude in from another angle is the altitude might go outside the triangle. Okay, so when you draw in a perpendicular, the proof gets a little harder because the altitude is outside the triangle. Okay, but that's our law of sines. Okay, usually they write it in alphabetical order in the denominator, A, B, and C. So that's how I'll write it. So sine of alpha over A equals sine of beta over B. We showed that. Equals sine of gamma over C. So law of sines isn't really that new of an idea. It's basically just taking right triangle trig, using that to come up with a fancy formula. You don't need this. You could go back and do right triangle trig every time. It's going to take longer because you're basically going to be reinventing this formula if you try to use right triangle trig this week. Okay, so just use the formula. We don't have to reinvent it every time. And important fact to keep in mind about all those angles, if you add up alpha, beta, and gamma, Carly, what will all those angles add up to?
180
Yeah, they always add up to 180. That's still true. But there's another theorem we used before we can't use anymore. What theorem did we use with right triangles that we can't use now? Because we don't have a right triangle. Kayla? Yeah, we can't use the Pythagorean theorem because we don't have a hypotenuse anymore. Okay, because we don't have the 90. We might have a 90. That would be like a special case. But in general, I'm not going to guarantee you any of the angles are 90. Right. So let's just go through a problem. All right, so first thing we want to do is set up a table. ABC, alpha, beta, gamma. Fill in what you know. Alpha's 20, beta's 60, A is 4. I'll put boxes around what I need to find. Now, eventually, I need to know whether I should use law of sines or cosines. That's obviously a moot point this week. But I'm still going to sketch the triangle so I can see what type it is. Okay, but before I do that, what's gamma? We don't need to know the type of triangle to find gamma. Josh?
100.
It's 100. Okay. Let's draw out our triangle. I don't draw it to scale. I just keep A across from alpha, B across from beta, C across from gamma. So A is there, alpha is there, B is there, beta goes there, C, gamma. Okay, what kind of triangle is this? Got two angles and a side, but how would you describe it using the three letters? Yeah?
SSA.
Do you know two sides, SS?
Oh, I'm sorry. Angle side.
Yep, you could say, yeah, you could say it either way. You could say angle, angle, side, or you could say side, angle, angle. Doesn't really matter. There are some of these that it's less polite to write in the opposite order, so we won't. But this isn't one of them. So, same thing. Because it's this type, that is one of the three types I wrote that you use law of sines for. All right. When we did right triangle trig, I said, don't ever use something you found to find something else for two reasons. One, it could be wrong. Two, if you rounded it, it's not as accurate. Well, this week, we're not going to be able to do that. You're going to have to use things that you've calculated to find other things, which means if you make a mistake on one part, it is possible that the other part is also automatically wrong. Okay? We are going to be able to find B separate from C. So we could get B right and get C wrong. But if we got gamma wrong, I guarantee you C is going to be wrong. But gamma has no effect on D. Right? It's basically you look at what's in the rows. Another way to figure out that it's law of sines when you make this table, if you have a row that has both pieces of information in it, it's got the side, it's got the angle, that's a law of sines problem. If you had, for example, a side, and a side, you wouldn't have a row with everything in it. Each row would be missing something. That's how you can tell it's not law of sines. All right? So sometimes I just look at the table, look that I have a row with everything in it. All right. So first thing is we're going to start with that row, the row that has everything in it. And we're going to plug this row into the law of sines. Okay, so first part of law of sines says sine of alpha divided by A. So sine of 20 divided by A. And now we can find B or C. Let's do B. If I'm going to find B, what do you think would go in the top on the other side of this equation? Yeah?
Would it be beta?
More than just beta.
60?
More than just the 60. Okay?
Sine of 60.
Sine of 60. So it's sine of an angle divided by a side equals sine of an angle divided by a side. Okay, and what side would go in the bottom? B. Okay, now, since I know A, I'm going to fill it in. I could have done that right away, and I should have. So sine of alpha over A, and I know both of those. Sine of beta over B, and I know one of those. When you set this up, okay, this is a proportion, you can only be missing one letter. Okay, and we are. We're only missing one letter. What's the technique to solve a proportion? What do you do? Okay, cross multiply. So we get 4 sine 60 equals b sine 20. Okay, our last step is going to be to divide by the sine of 20. We don't have to figure out what that is yet. Now we have to figure out what it is. Okay, so we'll type it in and just round it to 3 decimal places. 4 times the sine of 60, divide by sine 20. And nothing I'm doing here requires a graphing calculator. It's just easier for me to type it in on this one than the Windows calculator. So type that in. And we get about, oh, what did I do wrong? Simple mistake. I knew a side can't be negative. I didn't type anything in wrong. I typed everything in perfect.
Then it's not in
Yeah, these problems, 60 degrees, 20 degrees, all of these problems are in degrees. You will not be using radians for any of them. But that's a good mistake to make because a lot of people make that mistake. They get a positive answer, and then they never realize they were making mistakes. I recognize it because of the negative. Okay, so B is 10.128. Right, now we'll set up the law of sines one more time to find C. I have 2 rows that are complete. I've got to use one of them to help me find C. Which row should I use? Yeah?
The A row.
Yeah, use the row that has A because it, why?
We were given a.
Yeah, we were given it. Okay, so at least we know that that part's right. So the sine of, what was it, 20 over 4 equals, and what am I going to put on the other side to solve for C? Okay.
Sine of 100 degrees over.
Sine of 100 over, we know gamma,
C.
C. Okay, cross multiply. When you do it all out, get C by itself, it's going to be 4 sine 100 divided by sine 20. Okay. And just type that in. 4 sine 100 divided by sine 20. Okay, we get 11.518. Okay, and as always with any triangle, the biggest side should be across from the biggest angle. Smallest side should be across from the smallest angle. If that didn't happen, something's definitely wrong. But this looks reasonable. Okay. Any questions on that one? So we have 2 more. See if we can do them. This time I already have the diagram drawn for you. What type of triangle is this one? Yeah. True. It might be acute. We'll figure that out in a second. But in terms of the 3 letters.
Isosceles.
So the 3 letters I'm looking for, like side, 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 or
Oh.
side, angle, side, or
angle side angle.
This is angle side angle. It's not the same type as the last one, but it is another type where you use law of sines. We know the angle across from B. So Sam, what's the 40?
Beta.
That's beta. We know the angle across from A. So Brian, what's the name of that angle?
Board.
Yep.
I mean, board map.
And the name of it?
Alpha.
Alpha. Good. We don't know gamma. A we don't know. B we don't know. But C is the angle, is the side across from gamma, and we know it. Now I said to use law of sines. You got to have a row in this table with everything complete. We don't right now, but can we get a row complete pretty easily? Nick?
Gamma is 95.
Yeah. If you just take 180, subtract 45, subtract 40, you get 95. All right, so it turns out it's not an acute triangle. It actually is just barely obtuse. But it's very important we get that one right. We're going to use row C to find everything. If row C is wrong, everything's wrong. Okay, so let's set up our problem. We've got the sine of the angle divided by the side across from it equals sine of an angle divided by the side across from it. Cross multiply. You get 4 sine 45 over sine 95. If somebody can figure out what that decimal is, I'll set up the second part. The second part, you're going to use the same left-hand side as before. Sine of 95 over 4. Except what's going to go on the right-hand side this time? Josh?
Sine 40 over B.
Good. Sine 40 over B. Okay, and B, cross multiply. That's 4 sine 40 divided by sine 95. Okay, anybody get the answer for A? What the decimal comes out to? Okay, everyone think they could find the decimals on their own? Yeah?
It comes out to 2.839.
2.839? Okay. And B is going to be very close to it. It's going to be a little bit smaller because beta is a little bit smaller. Okay. Any questions on that type? Okay. Then the third type. The third type is side-side angle. Okay, this type is a little tricky. Okay, we're not going to look at all the cases of it today, but there are 3 separate cases you could have. And with what you guys already know, it actually isn't that tricky because you already know how to do the tricky part. It's something I taught you weeks ago. And we've used it yesterday and the day before too. It has to do with where the other answer could be, figuring out which quadrant it could be in. So side-side angle could have 1 solution, 2 solutions, or no solution. Okay, so let's set it up. So A is 3, B is 2, and alpha is 40. Okay, I know it's side-side angle because I told you it wasn't the problem. I could sketch it. Or I can look at the table and say I got a row where everything is complete. That means it's law of sines. I also have a row that's completely empty. That's how I know it's the tricky case. Okay, I got a row that's completely empty and I have no way to find anything in that row. I cannot get C and I can't get gamma. So I'm forced to find something right away. What do I have to find first? Okay? I have to find beta first. The other problems you had a little bit of choice. This one you don't. So Carly, can you give me the left-hand side of my proportion?
It would be sine of 40 over 3.
Good. sine of 40 over 3. And then I'm going to put sine of beta over 2. Okay, as I solve that, I'm going to get 3 sine beta equals 2 sine 40. Divide each side by 3, which it's okay, I'll just do that in that step right there. And now I've got to get beta by itself. How do we get beta by itself here? Yep.
Take the inverse sine of both sides.
Take the inverse sine of both sides. So beta equals inverse sine 2 sine 40 over 3. So inverse sine of 2 sine 40. And make sure that divide by 3 is still inside the inverse trig function, which it is. We get 25.374. I'm going to write that answer in the top part of the box, because there could be a second answer. Okay, basically, you just found your reference angle. If there is another answer, what other quadrant does sine come out positive in? Quadrant, yeah, 2. Okay. What would I do with my reference angle to get an answer in quadrant 2?
Subtract it from 180.
Subtract it from 180. This could be another answer. So if there's another answer, that's what it is. It's 154.626. I'm just going to write it over here. I want to look at it. And I want to figure out, is it possible for that to be another answer? Sometimes it is, sometimes it isn't. What do you think in this case? Yeah?
No.
No. Why not? Why can't you use this?
Because if you add alpha, which is 40, it's already more than 180.
Right. Go back and look at what was given. Okay? Look at what your other answer could be. Add them together. If you add them up, that's 194. The second answer is too big to work. Now, let's say the second answer came out to 100. Then it would work. That would have been small enough. This one is too big. So from this point forward, we've ruled out that there's a second answer. You don't have to worry about a second answer for the rest of this problem. You just solve it normal. Okay? So now the next thing I do is get gamma. Do 180 minus 40 minus 25.374. Now I've got 114.626. Now I finally have a piece of information in that last row. I can solve for C. Okay. So to solve for C, you'd use your first row, sine 40 over 3, and your last row, sine of 114.626 over C. And there wouldn't be a second answer. We've already eliminated that option. Okay. So I wrote out everything that you guys already know. To check if there's a second answer, you guys already know this. It's 180 minus your reference angle, because you're in quadrant 2. And then you got to check and see if that angle and the given angle could fit in the same triangle. Okay, so we found the second answer, but we were given a 40 to start. Add them up, too big. They don't fit in the same triangle. Okay, so you guys, I wrote this out for some classes that aren't as familiar with finding the reference angle and getting the second answer. You guys already know how to do all that. Okay, so the homework tonight, I tried not to put any that have 2 solutions. I went through them quick. If you come across one that does, and you get stuck, don't worry about it. We're going to go over it in class tomorrow. We'll go over 2 solution and no solution. Okay, so page 435, 4, 9, 11, 13, 14, 18, and 19.